Hello, how do we solve this logarithmic equation? Log x base 4x plus log x base x over 2 equal to 2. Solution. The first thing we should have in mind is that this logarithm is in base 2. We have log x base 4x plus log s base x over 2 equal to 2. We can simplify each of these logarithms. Recall that log a over log b is equal to log a base b. Applying this property to this guy, you will see that our a is x and b is 4x. So from here we have log x over log 4x plus, applying this same property to this guy, we have log x over log x over 2 equal to 2. Let's proceed further. Also, recall that log AB is equal to log A plus log B. So from this line, we have log x over, applying this property to this guy, we have log 4 plus log x plus log x over. You will notice that log x over 2 looks in form of this property. Let's say we have log a over b. This is equal to log a minus log b. Applying this property to this numerator, we have log x minus log 2. This equal to 2. Since these logs are in base 2, each of these logarithm is in base 2, we can rewrite this guy as, consider this first, that will be log s base 2 divided by log 4 base 2 plus log x base 2 plus, this also will becomes log x base 2 divided by log x base 2 minus, this will become log 2 base 2 equal to 2. Let's proceed further. Log x base 2 over log 4 could be written as 2 square base 2 plus log x base 2 plus log of x base 2 divided by log x base 2 minus log 2 base 2 equal to 2. Let's proceed further. So we have log x base 2 over, this whole guy could be written as 2 times log 2 base 2 plus log x base 2 plus log x base 2 divided by log x base 2 minus log 2 base 2. This equal to 2. Now, recall that log a base a is equals to 1. So from this property, it means that log 2 base 2 is equals to 1. So have it in mind that we have to replace this log 2 base 2 with 1. From this line, we have log x base 2 over 2 times 1, since log 2 base 2 is equals to 1, plus log x base 2 divided by log x base 2 minus, we know that log 2 base 2 is simply 1, so we have 1 is equal to 2. Let's proceed further. Sorry, something is missing here. Plus log x base 2. So we have log x base 2 divided by 2 times 1, that is simply 2, plus log x base 2 plus log x base 2 over log x base 2 minus 1 equal to 2. you will see that something is very common on this left hand side. Log x base 2 is common. So let's suppose log x base 2 is equals to m. From here, we are going to have m over 2 plus m plus, in place of log x base 2, we write m. So we have m over m minus 1 equal to 2. Let's proceed further. It is very possible to take the LCM. The LCM will be m plus 2 times m minus 1 over this 2 plus m is the same thing as m plus 2, just the rearrangement. So now m plus 2 times m minus 1 divided by 2 plus m, we'll be left with m minus 1. So we have m minus 1 times m plus 2 times m minus 1 divided by m minus 1. We'll be left with m plus 2 times m. This is equal to 2. Let's proceed further. Let's open this bracket. M times m, that is m square. M times negative 1, that is minus m, plus m times m, that is m square, plus m times 2, that is 2m, divided by m plus 2 times m minus 1. This is equal to 2. Let's proceed further. M square plus m square, that is 2m square, 2m minus m, that is plus m, divided by m plus 2 times m minus 1. This is equal to 2. Now, let us cross multiply. 1 times this numerator, that will be 2m square plus m equal to 2 times this guy, that will be 2 times m plus 2 times m minus 1. So we have 2m square plus m equal to 2 m times m, that is m square, m times negative 1, that is minus m, 2 times m, that is plus 2m, 2 times negative 1, that is negative 2. So we have 2m square plus m equal to 2 into m square, 2m minus m, that is plus m, minus 2. This means that 2m square plus m is equal to 2 times m squared, that is 2m square. 2 times plus m, we have 2m. 2 times negative 2, that is negative 4. It is very obvious that this 2m square, we cancel out this 2m square. We are left with m equal to 2m minus 4. This means that 2m minus m minus 4 is equal to 0. By rearranging this equation, 2m minus m, that is m, minus 4 equal to 0. Clearly, from this line, m is equal to 4. Now, since log of x base 2 is equal to m, let me show you where we got this equation from. It's actually from this line. Let's proceed further. This means that log of x base 2 is equal to, what is m? M is 4, so we have 4. This means that x is equal to 2 raised to 4. That is, from this property, let's say we have log x base a equal to b. To obtain the value of x from this equation, x is equal to a raised to b. That's how we actually got x equals to 2 raised to 4 from this property. So x is equal to 2 raised to 4 is 2 times 2 times 2 times 2, which is 16. This is the required solution for this logarithmic equation. That's it. Thanks for watching.